All right, guys, welcome back to AMMA SAT. So we're going to talk about the ninth episode, and this time let's see what we're going to talk about. Actually, I have lost the track. So we have almost covered most of the part in the advanced math core. We have reached the last one, exponential models. We're going to use the exponential functions to solve some of the real problems. I guess that's what it means. Let's just click in and get into the problem here. So for example, you have this problem here. The population of a town is 5,000 and it's growing at a rate of 4% per year. Which of the following function P models the population after T years? So we're going to go to the basics by looking at the chapter of the textbook. Let's just go to the textbook over here. You can use AMMA to lead you to the textbook, or you can get to the textbook within a few clicks. All right, so let's see. We are on the chapter now. So exponential growth and decay. So going up and going down. You have things changing both ways, right? So let's talk about growth. If you have something that is growing at 10% somehow, population, and then after 1 year, it's going to be different, right? So suppose you have 100 people for the first year, and the second year is going to grow for another 10%, which means originally you have 100 people, and then you have another 100 times 10% people added up on the top, right? So you're going to get 100 times 1 plus a 10%, and with a 1 year on the top. So that's 1 year. What if you have another year? Then you raise the power to 2. If you grow for another year, then you raise the power to 3, right? So that's basically how it works. All right, so we're going to take a look at this paragraph right here. So the key insight, a 10% growth means you keep 100% and add 10%. So the multiplier is going to be 1 plus 0.1, and it's going to be 1.1. So basically the population is going to be 100 times a multiplier 1.1 raised to the power n refers to how many years that you have been experiencing the growth. All right, and a decrease actually is the same logic, only you don't plus the 10%. You're going to take the 10% away. You're going to minus it, right? So a 15% decrease means you keep 100% but lose 15%. All right, so if the population is decreasing by 15% a year, so the expression is going to be 100, that's the original number, times the multiplier, which is 1 minus 10%. 15% in this case. It says 15 here. So this part is going to be 0.85 raised to the power of n, or n is the year that the number decreases. Correct. Just read these two. And then this part, we're good to go. So now, with this understood, we're going to go back to the problem. We know that the original number of the population of the town is 5,000. Where's my draft here? Okay, just let's move it to the right. So let's say 5,000 people. That's the starting point. And then it's growing at the rate of 4% per year, right? So then the multiplier is going to be 1 plus 4%. Right? And 1 plus 4% is equal to 1.04. Yeah, don't get this wrong. All right, and then which of the following function P models the population after T year? So after 1 year, it's going to be 5,000 times 1.04 raised to the power of 1. Then after 2 years, it's going to raise to 2. After 3 years, it's going to raise to 3. And then after T years, it's going to be raised to T, right? So that's basically how we get the final answer. So T, it's going to be 5,000 times. I guess this one is the only correct answer, B. All right, so let's check our answer. Yeah, we get it correct. And still, again, you can click Ask Emma to explain, all right? If you have downloaded the iPad app, you can have voice input and voice output just like a real tutor. All right, so then you have it to check B is correct. Yes, B is correct. So it checked it for you and explained a little bit, okay? So guys, I guess that's all for today. I'll see you guys next time. Bye.